Okay, hello there. I'm very glad to see you all, yeah, in here together with me. I hope that everything is fine. Please let us know in chat if you hear me well, yeah, and if you see my shared screen, yeah. We are gather today to discuss the event-driven approach, to development of the process applications using the Jmix BPM in particular, of course, and if everything is fine, we're going to start, of course. My name is Dmitry, by the way, and I'm the trainer, the Jmix platform trainer. I can introduce the trainings for you if you're interested for your company, and I'm very glad to see you all in here. The Jmix enjoyers, let's say I hope that some of our well-known ambassadors, are together with us as well, namely the Mladen, the Felix, the El Bahir, and the other guys. So those who are the ambassadors, the people who know the Jmix very well, who create the applications with Jmix, reach them, if you are interested in the Jmix development, and we are going to start our webinar, let's say, okay. So I have the presentation, as you can see, and the theme of the webinar on the first slide, what we're going to discuss, the agenda, let's say. Going to start with a little bit of a theory. Of course, we should usually start with the theory, in particular about the differences between the event-driven architecture and the linear one. Let's say we're going to build the processes. Of course, we're going to actually discuss and launch them. We have the application. I have the application, even a couple of the applications that are going to interact together with each other. How it's going to work, we are going to take a short look at the real life system, let's say. And of course, at the end of our webinar, we're going to have a short question and answer session. So what about the BPM? And what about the event-driven architecture? So differences between the event-driven processes and linear ones can be discussed, explained as follows. So about the linear processes, such processes usually represent a sequential chain of actions where each operation is executed strictly exactly after the previous one, and the process management follows a fixed predefined scenario always. Then the approach is of course is simpler to create, and simpler to handle. Usually this approach can be explained as something similar to a production line or the assembly line, where the task flow moves directly from the start to the end. These processes, of course, are easier, but this approach is not, let's say, not prepared to face the real world. The event-driven approach and the event-driven processes are controlled via events, of course, that can start the process, can interrupt the process, or can alter the course, the flow of the process. The process is split into a set of the event-linked stages interacting with each other. This kind of the process, let's say, allows us to react to external and internal events, in the real time, can provide the flexibility and the adaptability of the processes of the applications, let's say. The approach uses a message exchange architecture, of course, which is indeed called the event-driven one, where the process can interact concurrently, and asynchronously. This approach simplifies the handling of the complex, let's say, variable multi-instance or multi-user processes used in the modern automation systems, focusing on integration and dynamic response, of the application, let's say. So what the business process modeling and notation offers us to work with the event-based applications, event-based processes. So this is the slide from their website. As you can see, the notation itself has a lot of the things, a lot of the stuff. It has the activities, it has the gateways of different types, it has the conversations, career graphics, and stuff like this. Yeah, but we are most interested, of course, during this webinar in the events. Yeah. A lot of them, yeah, of those circles, let's say, circles with some signs inside them, envelopes, clocks, and so on. Some of them are implemented in the Jmix BPM add-on, yeah, and some of them are not. Let's take a short look at what we do have, yeah, and what we do not have. Okay. Here on the slide, you can see the classification, let's say, and some of the events are marked red, yeah, and some of them are not marked red. So those are which are marked red, of course, are not supported by some reasons. In fact, you just should know that the functionalities of those not implemented events, yeah, can be easily recreated using the other notation elements, yeah. So what do we have? We have the ends here, a lot of them, yeah, as it used on the second slide. Those ends are everywhere around us. So how can we classify them? Classify those ends? Of course, the first kind, let's say, of the classification is their place in the processes, where they are placed. Yeah. So the events can be start events, they can be end events, or of course they can be intermediate events, somewhere in between. Yeah. So they can be classified by their trigger. None means nothing going to start them automatically. Yeah. They can be triggered by the timers of different kinds. They can be triggered by the messages or signals. Yeah, they can be triggered by some compensations or some conditions. Additionally, they can be classified by the role. They can send something, yeah, publish something, broadcast something, yeah, or they can be expecting for some information, for something to arrive, yeah. So publishing or listening, let's say. They can be standalone or the task related. Standalone means they just placed somewhere in the flow, at the start, at the end, in the middle, yeah, or they can be attached. Namely the boundary events, yeah, which can be attached to the activity, to the task, let's say, and they can interrupt or non-interrupt a process flow. So the different types of the events classified by the interruptibility, yeah, let's say. Okay, so what we're going to create during this webinar, the application, of course, yeah, the process automation thing. In this webinar, once again, we will build an application for online order processing, yeah. Actually, not just a single application, once again, yeah, but a whole system demonstrating the event-driven approach. We will receive orders from the website, yeah, application. Then we're going to process them. We're going to create the delivery to deliver the orders to the customers, if orders can be delivered, of course, yeah. And if necessary, we're going to start the production, yeah, of new goods. So order intake service, some generation, the random generation, in fact, in our case, then the order processing service and the delivery service going to interact with each other, and we're going to use the RabbitMQ query, yeah, to accumulate the orders and then publish them, send them to the processing service, the processing application. So this is quite a simple scheme here. Yeah. For the from the point of view, let's say, of the analysts, from the analyst's eye, the process can be looking and can be described as follows, as on the slide. Yeah. So it's quite simple to understand. Of course, this is the linear one process, let's say. Yep. So order processing interacts only with the customer. Let's say at the very beginning we get the order, when then we check the availability of goods, then we can decide if we have enough of the goods or not have, of course. So if we do not have enough of those goods, we can notify the customer that the goods are unavailable, or we can try to process the payment from the customer. Then after this, we can notify the customer that payment failed by some reason. The most obvious reason, of course, in this case, that the customer does not have enough money, or we can confirm the order, and then we can notify the customers that the order was confirmed, so this is straightforward. This is the linear one, we're not going to create the processes like this. We're going to create something more useful, something more complicated. During this particular webinar, we're not going to have a single user task, not a single interaction with the application user with the business process forms, in a way. That, of course, this does not mean, that the users are completely excluded from the process. Let's say. Rather, there is no direct work with the process forms. No, I'm not going to neither create. We're going to neither to create nor show them, those forms to the users. The user, by the way, can interact with the process without the separate forms, using the visual elements of the application itself. For example, using the screens, the views, Jmix views, using the buttons, and so on, etc. This, of course, allows the seamless integration, of automation into existing applications, that used to exist before automation, and you can create this business processes seamlessly, okay, so next slide before we're going to the code, let's say. Inter-process interaction. What does this thing mean? One of the most important points in the event-driven development, just like in linear development, as well, is inter-process interaction. Different parts of our processes work differently, of course. What does it mean? So the departments probably have a different schedules. Some of them are working 24 hours, something. Some of them working 9 to 5, and so on. So the items, in fact, the orders, the client orders, customer orders, usually arrive the individually from the our web application, from the shop, from the market, let's say, but of course they can be delivered. They usually not delivered one by one, instead of this, they produced and delivered in some batches, in some big numbers, let's say. Of course, this cannot be packed into the same process, in a single process, and there is no need to do this. So one more slide, which tools we do have to introduce such processes. I mean, the event-based processes, how we can handle our situation with different schedules, different applications. We can start a processes by an event. We can stop processes by an event. We can use the attached boundary events. We can use the event-based sub-processes, of course, the call activities, let's say. We can use listeners for some events of different kinds. We can use the method brokers. In our case, we're going to use the RabbitMQ, and of course, we have the data model creator. Okay, so next slide. Going to the code, going to the demo. So what we are going to have modules, a couple of them, 2 of them, in fact. Modules in our case present as separate Jmix applications. They are stored, let's say, in different repositories. But of course, as you probably know, they can be assembled as a composite project, yeah, for easier work with the various applications. In our case, I had this event-based BPM as a root application, and this application includes two other applications. Yeah, first of them called the customer emulation. Yeah, and the second is called the order processing. At this point, I have both of them launched. Yeah, both of them launched. They do work. Yeah, on the separate ports on my host machine, of course. The first is the customer emulation, as you can see, and the second is the order processing. So what do we have in here? In the first application, yeah, we do have the control panel, as you can see. This is the screen, of course. This is the Jmix view. What can this view do? Yeah, of course, this can start the generation of the orders, or it can stop the generation. Let's take a closer look at this particular view: customer emulation, user interface view, control panel, and the controller. Yeah, something that we need here. We have a couple of lines of code, as you can probably guess. Yeah. Before show not interesting, the update charts not interesting as well. What is interesting is this start button click listener. Yeah. First step, of course, is to check if the RabbitMQ service is available. If it's not available, we're going to show the notification and going to do nothing, of course. Yeah, nothing, no reason to create the orders, yeah, and publish them somewhere else. If it is available, we're going to create the instances of the background tasks. Going to use the task handler to work, yeah, with the instances of such background tasks. Yeah, each task going to be launched. Of course, this task has a single method implemented, which is enough, yeah, to work with the Jmix background tasks. Namely, this is the run method, and what this method can do. This method can create the order DTO instance. This order DTO, of course, this is an entity which later after this can be serialized as JSON and published to the RabbitMQ. It creates this thing, yeah, order generator. Let's take a short look at this one. In fact, this order generator is quite a simple thing. It has a couple of the methods. A single method is public, only one, yeah, generate. And as you can see from this code, it creates some orders with the random address, random customer name, yeah, random item, DTO, created date is the moment of the generation, yeah, and then the event being published. The first thing, yeah, the first time we face the event in our event-driven, yeah, webinar. So what is this one? This is the, as you can see, order-generated event, and the application name and publisher events being used to create the instance and publish the instance. Yeah, this one is quite simple as well. It has the order DTO, the DTO entity linked with this particular event, yeah, and the getter method, as you can see, and who or what, yeah, listens to this particular event, yeah, when this event appears. We do have this in here in application, of course. So the application, sorry, listener for the order event listener, yeah. Handle order event, as you can see, we have the application settings add-on being used, yeah. In fact, this particular Jmix add-on provides the following screen, yeah, application settings, and you can create them, you can change them at the runtime. In our case, it's looking as follows, yeah. So number of attempts to detect address by coordinate, not so important at this point, yeah. Probability of the fake address, and the default values are presented here. And what is interesting for us at this moment, yeah, this is this RabbitMQ queue name. Yeah, it's orders or always orders. And after the moment this received queue name, I mean, yeah, the order DTO instance is received from the event, yeah, and after this, the message producer being particular supplementary being, yeah, let's say, sends the message to the RabbitMQ queue, yeah, RabbitMQ queue. Send message. What we do need for this is to know the queue name, yeah, and of course we need the JSON string, the JSON value, which is being serialized using the JSON object mapper. Yeah, everything is quite simple here. Okay, so let us start the production, yeah, of generation of the orders. Start. Orders generation started, as we can see, and we see the notifications here about the each generated order. So it has the customer name, it has some address near London, yeah, and here after the publishing, I did not show this, I'm afraid. Send message, not in here. Order event listener. Yeah, one more thing. Yeah, one more event to be published. Not so important for the application or for the processing, but in fact, as you can see, the user interface UI event publisher be used to publish the event about the fact that the message was sent to the RabbitMQ, yeah, is being published in here, and we do listen to this event in our control view, yeah, control panel view. So this is the event listener once again, but this one is available in the user interface, and we use this one to show the notifications, yeah, and we use this one to redraw those charts. Yeah, those charts, of course, are provided by the one more Jmix add-on, namely the charts add-on. Yeah, as you can probably guess. And here we can see which items are ordered, how many orders we do have, yeah, orders by items, how many foo we need, how many boo, and how many moo, yeah, we do need, and a couple of charts. Take a look, yeah, check out this charts add-on as well. It's quite powerful, yeah, thing. So I have this thing, I mean the RabbitMQ admin panel. Yeah, as you can see, I'm logged in. The Rabbit works, of course, is prepared in advance, and as you can see, the queue grows. Here we have 24, yeah, 25 of ready messages. Of course, we should somehow start to handle this queue. Yeah, where are we going to do so? Of course, we're going to do this in a second application. Yeah. Here we have the control panel view as well, yeah, and a couple of buttons in here, a couple of the charts as well. So what's going to happen once we start this reading from the RabbitMQ? Let's take a look at this one. I'm going to close all those tabs for now. They are not related to the second application, to the order processing application, and we're going to find this particular view in a second application, of course. So this is the customer emulation, this is the order processing. Here we need the user interface views, and this should be here in the demo view, yeah, control panel view. At the moment of the beginning of, let's say, the of the listening, yeah, of the queue, what's going to happen when the button is clicked? Start reading button. In fact, yeah, we are going to check if the Rabbit is available once again from the point of view of the second application. As you can probably guess, then we change the buttons appearance, yeah, enable, non-enable, stuff like this. And after this, stop, notification create, Rabbit available if started, else notification show. Give me a second, please. Give me a second. Control panel view, Rabbit service. Yeah, in fact, yeah, pressing the button just start the Rabbit service. Rabbit service is Rabbit available. Yeah. Rabbit service. So if it is available, of course, yeah, then in this service, at the startup, the listeners for the queue containers are being created a little bit later. Yeah, the factories, the connections, and the required stuff. Yeah, so we can actually listen to the queue. What else? We only have one method. Yeah, I mean, in the order message handler, this one should be used in here as well. Give me a second, please. Rabbit available, start listening. Yeah, the start listening method, and the queue going to be checked, of course. Yeah, and the all the following activities, yeah, going to be started, and the next thing we're going to use and going to take a look at is the order message handler class. Order message handler. Give me 10 seconds. I'm going to find this one. It should be in the application we're talking about. Yeah, I mean this order processing one. So app. Not app. I believe that it should be about the order message handler. So it's placed in the Rabbit directory. Yeah, order message handler. So as you can see, yeah, this is the Rabbit listener, as simple as this one, with the identifier, with the queue name. Once again, yeah, in this case, this queue is the orders queue. Yeah, orders queue, queues and streams orders. Yeah, this one. And we're going to start to listen the messages from this particular queue. Yeah, and we're going to start the order process. Yeah, using the additional bean. Once again, this is the main bean of the entire order handling process. Let's say, yeah, of this entire application. So what we're going at the startup. This is, by the way, the first place we are going to face the BPMN, yeah, stuff. So order record is going to be deserialized from the JSON, yeah, from the Rabbit MQ message, yeah. If it's null, we're not going to do nothing, of course. Then we're going to introduce something that we need in here, yeah. We're going to introduce a couple of the timers. Yeah, in fact, those timers are just to show the processes. Yeah, so the processes are not complete, yeah, or fail immediately after they started. So we can take a closer look at them. So this is the max delay timer, the first one, then the timer new and the timer verified, a couple of more timers. Yeah, in fact, as you can see, here we create the some random numbers, integers, yeah, ints even, and of course, since we're talking about the BPMN, about the notation, we should provide the strings, yeah, strings which are formatted in the particular form, yeah. So those must be the ESO 8601 strings. Yeah. Okay. So we change them. Let's say we convert them. Yeah. Seconds to duration. Then we're generating the business key, which is going to be important a little bit later. Then we getting the items. In fact, we do have 3 of them available, namely, yeah, boo, foo, and moo. Yeah, 3 of them. Receiving those and creating a map. Why do we need this map? We need this map to work with the process variables. Yeah, at the process instance, process existence. Yeah, time. Let's say So it's being created using the map, of course, string and object, and we are placing all we do need in the process inside this map. Order number, which is business key. Then we need the customer, we need the address, we need a quantity of the goods, we need the good itself item. We need a couple of the timers, yeah, to wait a little bit during the process. After this, we are going to try to start the process by its message. Yeah, start message name, which is the start order processing. This one, the very first string here that we can see. We need the business key and we need the map with the parameters in the process. And then we are publishing the event. In fact, we publishing the information about we do have the new incoming order. Okay, so start order process is quite simple one. Then let's take a look. Yeah. Okay. I'm going to show you the exception of the first step. Yeah, we do have how many? How many we do have? 134. Yeah, of the orders generated by our site. Let's say. So let's start the process. Yeah, the handling process. Nothing going to happen, of course, in here. Yeah, why? Because we do not have a single process deployed to our server, of course. But we do have a couple of the exceptions here, as you can see. Probably a little bit more than a couple. I believe that's something like 140 plus. Yeah, at this moment. Why? What's wrong? Of course, the exceptions are being thrown from this particular place. Yeah. The runtime service is being used, and it tries to start the process for each order. And of course, since we do not have those processes deployed, it throws the exceptions. Let's take a look at the processes then, shall we? Okay, so in the Jmix, we do have this BPM section in the Jmix view of our project. And in fact, in this one, we usually have two directories. First of them is used to store the process drafts, yeah, the drafts which are not going to be, automatically deployed nor published, nothing going to happen with them, yeah. And we have a second directory which contains the processes from the second directory, those processes can be deployed manually, yeah, or they are always automatically deployed when the application is started. Yeah. So the first process to take a look at, of course, this is the core process, let's say, yeah, and this is the order processing. In this case, this is a draft, yeah, but I can copy this to the processes, or I can duplicate this draft to change this one in a next version, yeah. So what do we have here? This is our main process, the top level process, yeah, the order handler, let's say. So what we're going to do in this one? The first thing, yeah, this is exactly the thing we are missing for now. This is the message start event, and the message name, as you can see here, is start order processing. Exactly the thing that we have in this in the order service, yeah, here, start message name. So once I deploy this process, this particular one, this can be and going to be started by the message. Okay, so let's do so. Let's take a look at this process. Let me explain this to you, what is going to do. Yeah, the first is the start moment. Then the process going to create an order. Yeah, this is the service task, so it's going to be created by this order service. In fact, yeah, as far as I remember, not so important. Yeah, in fact, so the order instance from the data model going to be created, of course. After this, we're going to wait for a little time, yeah, going to define the variable. In fact, we're going to place the order instance in the not the order instance, yeah, we're going to set the address, yeah, as the process variable from the order, yeah, entity. This one returns the order instance, yeah, and this is going to be present in the process variables. Then we wait a little bit, then we, yeah, this is the timer, one of the map parameters, yeah, we placed in the process when we trying to start this one. Then the first call activity, address verification, with the boundary event, which is the catch error event. Yeah. So if the address verification process is completed with an error being thrown, yeah, we're going to set the status of the order out of zone. Yeah. If address is fine, if address is correct, we're going to set the order with a status verified. Then we're going to wait a little bit more. Yeah. After this, we're going to try to make the items reservation. We're going to check if we have enough of the items, of course. Yeah. If so, we're going to set the status ready. If we do not have enough of the items, we're going to catch the exception from this call activity. Yeah. And we're going to broadcast a signal. Yeah. Broadcast a signal. And we're going to end the entire order processing process. In that case, if the status is ready, we're going to send, we're going to make a decision that this particular order is ready for the delivery. Yeah, then it's going to be set to the status in delivery. After this, we're going to confirm the delivery. Yeah, and setting the status of an order to be completed, and finish the entire process. By the way, this particular signal, yeah, is going to be broadcasted in this process. Yeah, and this signal catch event, yeah, is waits, yeah, for this particular signal. It's going to change the status of the order to be cancelled. Yeah, then it's going to notify the customer, and then it's going to end the process as well. Okay, so let's copy this one to the processes. I mean this draft. Yeah, copy it. Perfect. Then after I copy this one, I can deploy this one immediately, and we can take a look. We can check if it was deployed in the, okay, I need the beginning, I need this, and I need the ending of the log. Yeah, so as you can see, yeah, as you can see, I deploy the process. I'm informed explicitly about this one. I am in log. So then I can take a look at this one in the process definitions in of the application. In fact, you can open this one in modular, you can change this one in modular, adjust somehow, yeah, and then redeploy if you need, or you can upload, download, and so on. So the definition, this process, this is a definition, yeah, this is the let's say process itself. It's not an instance, yeah, it's the definition of an the process, yeah, based on which later the instance is going to be created. The instances, we should have a couple of them, as you can see, something like 15 probably, yeah. So pay attention, they have the business keys. This is the ORD, means that this is the order process instance, yeah, and those are the instance numbers, of course. So during I'm talking about this, we created like 20 of the processes. What's next? Of course, in this process, we should call the address verification. Let's take a look at this implementation here where it is created. This is created, as far as I remember, process definitions describe the steps. Okay. Yeah, okay, the processes were started. Next step, it is important, yeah, to note that a separate process instance is created and started for each order, for each single order, yeah, which of course can end in one of several ways, as we know from this scheme, yeah, let's say from this scheme, yeah, indeed from this diagram. It can be ended because of the address verification, non-success, yeah, or if the reservation or payment is not successful, yeah, and so on. So each instance can end differently. Okay. What is also important here is that the process is non-linear. Yeah, it interacts with other processes using the messages and using the signals and using the call activities, for example. The next process to review and start to deploy, at least, yeah, is the address verification process. Let's look at this one. In fact, we can know which process to start from the call activity explanation, address verification. Yeah, this is a called element, and I have the draft for this, of course. Address verification process looks as follows. So this has a non-start event. Yeah, nothing to do with the messages. It started by the high-level, yeah, order processing process. So the first step, the first activity is to introduce the counter variable, yeah, with the value to be a 0. Yeah. Then after this, we're going to try to check the address. Yeah. So we are sending the request to the nominating service, yeah, which is from the OpenStreetMaps, yeah, let's say environment, something like this, yeah, and the results can be different. For example, yeah, first thing, nominating can return the error, for example, yeah. Then if it's so, we are going to, you know what? Let's take a look at this address verification. Bean, yep. Give me 10 seconds. Delivery, order, numeration, those are the views. I need the beans. I believe that it should be here. This is the order processing app, address verificator, something like this. Yeah. So this, in fact, this bean does not verify anything. Yeah. Just publishes the event request send event. Yeah. And we are listening to this one. Process request event listener. Yeah. So the call to the nominating is being performed in here. So what about this process, by the way? Interesting thing that we have in here. Namely, this is the event-based gateway. This one, event-based gateway. I'm not sure if you see this clearly. Yeah, this looks as follows, like this one. What is this one? This is a special gateway that may be associated with several different events. In our case, we see 3 of them. The first is the timer event. This one initiates a retry of verification after some expiration. Retry, yeah, try to check this address once again. Here we add one to the counter, which used to be 0, and try this thing once again. The second event we are listening to in this event-based gateway is the OK message. OK message, yeah, the message that can be published, sent to this particular listener from this listener once again, yeah. So send message to process. Address OK, yeah, so the going to be sent to this particular instance of the process of the verification here, I mean, yeah, and going to finish this particular process, and after this the main process can continue, yeah, its work, or we can send from the same listener the fake address message. In this case, we're going to throw the BPM error, yeah, and this is exactly the error we are listening to. In here, yeah, and this boundary event broken something. Okay, Yeah, and once again, if the address is fake, the delivery cannot be performed to this address, we're going to set the order status out of zone. Okay, so let's deploy this process because our processes are not working now. Of course, yeah. Why? They're trying to publish the events to the process which do not exist yet. So copy to the processes, then hot deploy this one, not add those to the Git. It's redundant, of course. Process deployed, address verification, BPMN. Let's take a look at our process instances. Process definitions, two of them, of course. This is the order processing, and this is the address verification process. Those are the orders. In a couple of seconds, I believe we should start to see the address verification instances in here. By the way, you can check the process in the diagram view. Yeah, so this is the process of the verification was completed somehow. Yeah, let's check how. Process instances, business key. Yeah, this is the order process. This is the address verification. Yeah, in fact, after those steps are being performed, we can see the results in a control panel. So we have up to almost 100 of the new orders. Yeah, we have like 20 of them verified, a couple of them out of zone. And in fact, I didn't show you this before. We do have the orders view, yeah, on which we do have the map add-on being used. So this is London, as you can see, and those are the orders which are verified, yeah, as you can see. Okay, so perfect. What's next? What is the next step, by the way? Let's close this one. Let's close this one. Order processing, yeah. So some of the orders going to be cancelled, yeah, going to be set as the out of zone, and we are not care about them, of course. Then if the address was okay, as we already know, then we're going to set the status of this particular order as verified. After this, we're going to wait a little bit more, yeah, a little bit of time using the second timer, yeah, timer verified. Then we're going to try to perform the reservation and payment. This is the another process, yeah, the process interactions once again, and this is the reservation and payment process. Let me show you this one. Going to the Jmix, going to check, find, yeah, this reservation and payment process and how this one looks like. This looks like, you can see, yeah, this particular way. What about this one? This process also has a specific event-based related features, as you can see. In particular, it includes the compensation activity. This one, yeah, this one, compensation activity. The first step is trying to, this one as trying to reserve the necessary products. This one, do reservation, yeah. And then upon the successful reservation, after the reservation was performed, in fact, yeah, the process attempts to perform the payment, the next step in this process. Let's look more closely at this service task, the implementation of this and this, yeah, methods of this service task. So we do have them, in fact, in the order service. In this one, in the main one, yeah, you remember I promised that this service is going to be the most important, the main one. So what do we have here? We have the methods, of course. The process started, not interesting. Simulate payments, not ready to check this one yet. Yeah, the do reservation, the first one. This is the inventory message provider being used, send inventory message. So we're using the additional service. Yeah, we're using the RabbitMQ once again for such things. In fact, yeah, the reservation can be successful or not successful. Yeah, no response or the response equal null means that reservation failed for this order. Yeah, or the reservation for order can be performed correctly. Yeah. Okay. So in this case, we do let the main process know about the result. Of course, pay attention once again. One thin point in here. Yeah, let's say order processing, reservation, and payment. Yeah. Okay. We performed the reservation correctly. Yeah, we are happy. Then we are going to try to make a payment, and we are not happy with payment by some reason. Yeah, in fact, make payment method is just a step in our application. Yeah, this is like this. This is the simulation, as you can see. Simulate payment, then the random error going to be checked. The random error is some value, as you can see. So this is a quite simple thing. And what if the error was present? Yeah, what if the error is present? Yeah, so we cannot perform the payment. What's going to happen? You should remember, yeah, so that we performed the reservation at this first step. How we can cancel this one? For this, for such cases, for such scenarios, when we made successfully a first step and we failed on the second step, and we must undo somehow the first step. Yeah, in the BPMN and in the Jmix BPM, we do have a thing called the cancel. Yeah, this particular activity called the compensation pattern, compensation activity. Yeah, this one. So if we did not perform the payment successfully, yeah, we're going to cancel the reservation. As you can see, this throws the cancellation request, compensation request, and this is a boundary event of this particular task, and this can cancel the reservation. Of course, the engine knows inside it, yeah, if this first step was performed successfully. Yeah, if it used to be performed successfully, then the cancellation going to be performed. If the first step was not successful, then even the attempt of cancel something that was not successful, yeah, not going to be performed. Okay, so this is the compensation pattern. Okay, what else? Let's copy this to the processes, of course, add this one to Git, not add, not important. Hot deploy the process. And now we should be able to see the other process definitions on the other process instances address. Yeah, can you see them? Address, reservation and payments. Those are going to be performed immediately, yeah, in just milliseconds, because we're not waiting in here. As you can see, not a single timer event. So some of our orders should be changed. Yeah, their statuses should be changed to ready. Yeah, it means that the goods were reserved, as you can see here. Yeah, this bar, and the payment was performed successfully. So they are ready. What does it mean? They are ready. It means that they can be delivered. They can be delivered. Yeah, order processing. Now, after the success, we waiting in here. Status is set to ready. Yeah, and we in fact do nothing in this process. We do nothing. We just waiting. We are this wait state. We are waiting before those orders change their status. Yeah, so all the processes are just waiting. We can make sure that this is they do in fact wait. Address verification, order processing. I need some order processing that waits. This one, for example. Yeah, not sure where this waits. Let's take a diagram. Yeah, it's going to cancel. Not so interesting. Not this one, I believe. Give me couple of seconds. Process definition, order processing, yeah, completion state active, yeah, apply the filter, and probably this one, the diagram. Yeah, this one is fine. Yeah, it waits here and waits here at the same time. Yeah, so how we can deal with this delivery? In fact, a couple of the ways. Yeah, I am explained during the theoretical part. The first way is to assemble. Yeah, let's say a number of the processes to deliver. Yeah, let's say we are sending the car, the truck, probably vehicle, when we have 50 of the goods to deliver. It's the first way. In our case, we working with this differently. Yeah, the first way, if we have enough of the goods to make this good for our profit, let's say, yeah, or we can start the deliveries by some schedule, and this is the case in our application. So we do have this delivery process draft, yeah, and this one waits for the message to start. And what is this one does next? It goes to the database, searches for all the orders which are ready, which do have ready status. Yeah, then it starts to create the it starts to perform the delivery. After this, of course, it changes the status to be delivered. Yeah, here we see the cross processes interaction. So the first thing, yeah, we are going to create a delivery, which all those orders, yeah, then for each order in this set, yeah, we are about to deliver, we are publish the messages to the particular instances of the order processing processes. Yeah, then in here we changing the status in delivery. Yeah, so they cannot be delivered again. Yeah, and after this we confirm the delivery and we setting the status completed. So set status, wait for the delivery to be completed. Wait for the delivery to be completed. I mean this thing, wait, yeah, then performed, then delivered, yeah, and stuff like this. So let's let me deploy this last process, delivery process draft, copy to the processes, not adding to Git, and then how deploy this one, yeah, and now the entire processing should be completed. Address verification, delivery process, yeah, some instances must arrive, but by the way, about the quartz. Let's check if we do have the job. Yeah, we do not have a job, of course. I should create this one. Nothing to do with the delivery yet. Let's create a quartz job. Let's say each minute probably. Yeah, we should start the delivery. Class company order processing quartz delivery job. Indeed, yeah. And then let's create the trigger. Probably I should create the simple trigger. Execute forever, repeat interval, not as small. Let's say, yeah, let's say 10,000 milliseconds, 10 seconds mean, yeah, start immediately, smart policy, stuff like this. Okay, and then save the job. And the goods must start the being delivered now. Yeah. Deliver source, message sent, order in delivery. Yeah, order status set in delivery. So all those waiting orders, yeah, there used to be a lot of them. Now are going to be delivered. Yeah, and in fact, the some goods should be delivered at this point. So the orders and the status are different, as you can see. For example, some canceled, some delivered, yeah, some of them are new, yeah, and stuff like this. And in fact, as you can see, this is quite powerful thing. Yeah, a lot of the processes process instances of a different kinds. Yeah, that's I believe mostly it about this one. Yeah, so in this webinar we got acquainted a little bit on the surface probably with the concept of event-driven development. Yeah, everything waits, everything publishes something, listens to something. Yeah. And its specific use in the Jmix BPM, as you can see, this approach, of course, enables building flexible, scalable, and adaptive business process that can dynamically react to external or internal events, react to something. Yeah, using the example of online store, online shop, let's say, yeah, a practical implementation of the event-driven approach was demonstrated, yeah, starting with order generation in the module, yeah, and asynchronous processing in another module, integrated using the RabbitMQ, yeah, and the complex interactions between the processes were showcased, including the things as the collectivity, event-based gateway signal, message publishing, and some retry mechanisms and stuff like this. And in fact, yeah, this is the time for our question and answer session, I believe. Yeah, so that's mostly it for today. Thank you very much. So if there are any questions, please introduce them. Let's say, yeah, use the chat. Mm-hmm. Yeah, by the way, use this one to start with Jmix BPM. Pay attention to our training courses. Yeah, we performed the Jmix BPM course like a couple of weeks before. Yeah, couple of weeks ago. If we do have the pupils, yeah, the students, we of course going to perform this once again. Okay, a couple of more minutes, yeah, of waiting for the questions. Probably 1 or 2 minutes. Remember about our other channels, yeah. I mean the forum, the our Slack channel, and stuff like this. Yeah, reach out if you are interested in the Jmix, yeah, and if you are interested in the Jmix BPM in particular. Okay, so as far as I can tell, yeah, as far as I can say, there's no questions. Probably is because I'm a very good performer, yeah, and everything is absolutely clear. So that is for today. Thank you for joining us, and I wish you well. See you.